So recently, a viewer of mine, Steve Truman, reached out to me, saw me struggling with my ZX Spectrum, and very kindly offered to send me a memory tester for it. And I very greatly accepted. And a few days later, here it is. Not only has Steve very kindly sent me the PCB, but he's also sent me all the other components as well, which is really amazing. Let's have a look. So hi Simon, I've tried to put everything in pack and think everything is covered other than the jumper tops. If memory serves me correctly, I've already programmed the Arduino. That is going to be amazing if that's the case, because I haven't got the first idea on how to do that. He goes on, to set up the voltage regulator I used an old Nokia phone charger and just cut the end off to give me a temporary supply, then turn the little screw to get my 12 volts. The 5 capacitors are 50 volt and I think 25 would be better physically, but the 50 worked fine. I used 4 individual jumper legs to solder the voltage regulator to the board using the through holes. Just cut them off the strip. And then there's a link to the GitHub. Any questions, just shout. Steve. Well, Steve, thank you very much for that. I think if I can get this working, it's going to come in very handy indeed. So before I jump into the video, I'd like to give a quick shout out to my sponsors for this video, which is PCBWay. If you're not familiar with them, they're a fantastic company. They've been in the market now about 10 years. They manufacture PCBs, they do CNC machining, 3D printing. The prices are very competitive and the service is extremely good. I know that as a customer long before they started sponsoring my channel. They very kindly 3D printed and sent me this, which is a cover for one of my smart cards for the Spectrum. Really great service. Link is in the description. Please check them out. They come highly recommended. So let's get this unbagged and see what wonders await us. So then we've got the PCB, the ZIF socket, we've got a couple of chips under there. Not sure what those are. Is that a reset switch? There's some sort of reset switch under there. Got some board pins, some capacitors, some resistors. Not sure what that blue thing is. Is that some form of diode maybe? I'll have to look that up. So we've got those. Little capacitor. Let's put the capacitors together. Another resistor. Let's tip everything out. Some more little capacitors. Try not to lose them. Right, that's the bag empty. And what have we got in here? Is that going to be the voltage regulator? I think it will be. Put that to one side. Not sure what that is marked up on there. Let's have a look. Oh, the little display. How fantastic. Move that to one side. Then in here, we've got the Arduino, I think. Some legs. There it is. Fabulous, absolutely fabulous. So I think the thing is, let's get this masking tape off and see how the board's labelled up. I might need to look at the images on GitHub to see what goes where. This is quite exciting. There we go. Right, so what have we got there? Arduino goes there. The voltage regulator there. Resistor, bank resistors, capacitor, the display. Those will be for those barrel style capacitors, whatever you call them, I can't remember. Funky little ZIF socket. Right, I'm just thinking. I think before I begin soldering, I just want to find out what resistor wants to go where, because I don't necessarily want to solder that on first, as I'm thinking that's going to get in the way of doing the resistors. We'll start off doing all the resistors first, the capacitors, and then we'll start doing the bigger stuff. Less likely to start getting in my own way then, isn't it? Right. So I've just been checking the schematic and all these resistors here. I'll just take those chips off for now. And the switch. All these resistors are 5, 6, 7, 2, 3, 4, 8, 9, 10, 11, 12, and 13. They're all 47 ohm resistors, which I've checked the banding on here. Yellow, purple, black. They're all 47s of these. So just going to bob these through the board. before I go chuck a chip in, these jumpers, 1, 2, 3, it's quite simple and straightforward, even for me. All the way up, and it tests the 4164s, all the way down, and it does the 4116s. So up for upper memory, down for lower memory. Right. So they're all currently up at the moment. Excuse my arm. Let's bob one in. Little dot up to the top. That's it. Right, and apparently you just press and hold briefly, and then it will start the test. That is friggin' brilliant. I have wanted a way of testing chip memory for some time for the Spectrum. And this is just going to be absolutely perfect. Take all the guessing work out of it, hopefully. Right. Let's try one of the lower memory chips. Right, let's move these jumpers. Right, let's connect the power back up. Right. Let's give one a whirl. Dimple to the top. Cross our fingers. Press and hold. Ooh. Error. Okay, so that's potentially iffy. Let's try another one. Potentially good to know. I wonder if I didn't push it down far enough. Is that another faulty one? It's running now. Yeah, that one may seem to be a faulty chip. Let's try the others then. Let's just try that one again. Because it didn't want to work first time, did it? Right, so that one does seem okay. So let's put that a good pile over there. Let's try another one. Dimple at the top. So just to summarise this fabulous little thing, I went on to do some further tests. If you've not seen my previous video on this Nightmare Spectrum, I do suggest you watch it. You might be quite entertained by it. But I took all the upper RAM chips out of this and tested it. 7 out of the 8 failed. The diagnostic ROM reported back IC18 had failed. When I've tested them all on this, like I say, 7 out of the 8 had failed. I'd never have discovered that without this. In relation to that computer, I do digress slightly. I strongly suspect there was a huge problem with voltage through the board, and it wiped out several of the chips on it. I'll never know because I don't plan on doing anything more with it. But there you go. This is going to be in my toolkit now. It's going to be an essential little thing for working on the Spectrums. So thank you again, Steve, for that. I'm eternally grateful. So as always, if you've got this far, thank you so much for watching. I hope you really enjoyed it and got something from it. If you'd like to support me and my channel and my costs, there's a link in the description to buy me a coffee. And I'd also appreciate a thumbs up and a subscribe if this is the sort of stuff you enjoy seeing. In the meantime, take care, and I hope to see you again soon in another video. Bye for now.